I'm the Product and Applications Manager for some of our newer Ethernet products, and one of these lines of products are switches. So we have two devices that are going to be available later this year, the RAD-Jupiter and the RAD-Pluto. I'm going to go over a little bit about what the switches are, some use cases for them, and explain how you might use them in unorthodox ways to get to do your job. So if you're not familiar with intimately familiar with switches, they're layer 2 devices, so they really only care about sending frames addressed by MAC frames or the MAC address. And so when you're talking layer 2, you're not dealing with the higher layer protocols that deal with fragmentation and establishing connections and acknowledging flow and some of the problems that layer 3 and layer 4 protocols deal with. So it's strictly passing 1500 byte Ethernet frames around based on physical MAC addresses. So if you look around and see different switches available, you'll see a variety of terms, anything from managed switch to smart switch to unmanaged switch. And depending on what article you're reading, some of the terms are designated purely as marketing by a particular company to make their switch stand out. I break them down into 3 different categories. The unmanaged switch, which is your bare bones, plug in your Ethernet cables and let it go. Little or no configuration, MAC-based routing. So unknown MAC addresses or Ethernet MAC addresses are learned by the switch. It builds an address table and determines where to forward those over time. There might be a little bit of configuration available on an unmanaged switch. You might be able to statically define an L2 table, an address table, so that there's no initialization at the beginning, but much more functionality than that. I consider it a smart switch. And so a smart switch has a little bit more things to deal with VLAN support, quality of service, static configurations of that, enforcing VLAN tag rules and priorities, being able to tag and untag, and then also maybe some port mirroring. Now, what I consider to be a managed switch is it enhances quality of service and security. You're really adding a host processor on the board with the switch to do a number of different things. It can be managing some protocols, dynamic VLAN management or MVRP, where devices can register with the switch to be on a particular VLAN, managing redundant paths, the spanning tree protocol or rapid spanning tree protocol, all of the AVB TSN protocols. All of these protocols require a host processor or an embedded core in the switch to be able to do this. It's not strictly a state machine. Additionally, they have hardware resources on there to support deep packet inspection and then ingress policing and limiting. So our first switch available is called the RAD-Pluto, and it's a 5-port smart switch. It's based on the NXP SJA 1105, if you're familiar with the components available today. And it's got a total of 5 ports spread across a couple different media. It integrates CAN, LIN, and our Core Mini processor, which, if you're familiar with our products, does embedded scripting and enables you to do things like filtering and gateways and those types of applications. And we'll talk about some of the use cases in the following slides. But to really understand the capabilities of this, I'll show you a block diagram. So we start with the SJA 1105 switch from NXP. And so it has 3 100 base T1, 100 megabit 2-wire Ethernet ports. And then we have one port that has MUX, so you can choose between a 4th 100 base T1 port, or 1000 base T, or your standard 8-wire gigabit RJ45 jack. And then the last port, we also have a mux, so you can either run it through a gigabit USB bridge, so you can plug that directly into your computer, pretty much like Ethernet, an RJ45 to USB dongle, and your computer has a NIC directly connected to the port of this switch, or the core mini processor. If the traffic's gated through there, then you have the ability to run scripts. You can run the Ethernet traffic directly into Vehicle Spy and log it. So that's another feature in this. Now we're going to have two versions of this switch. One's just going to be a base switch with all the smart switch configurations, and then the other one is going to be with the CAN and LIN and core mini integration. So one simple and almost trivial application that you could use the switch for is media conversion. And in this case, the configuration of the switch is you're basically setting the properties for each port. So in NXP's terminology, or the way they've architected their configuration, you do this in three different configurations. One's the broadcast domain, which will either block or pass broadcast messages from a specific port. Reach port, which is really an egress traffic cop. So if the reach port checkbox is not enabled, then that port is effectively blocked. And this is also known as port-based VLANs, if you heard that term before, where you're exclusively connecting two ports and then excluding other ports in an effect, creating a port-to-port connection or multi-port to multi-port connection. And then the last configuration is the flood domain. So that's when a switch doesn't know or doesn't recognize a MAC address, it's not in its table, it will, if it's configured to, flood all the ports with that address. In this case, you could block flooding of unknown addresses to specific ports. So if I wanted to do media conversion between 1000 base T and 1000 base T1, I'd connect ports 1 and 2. And you can see in this chart, it's really a matter of these red X's, or these red check boxes. This says anything ingressing on Automotive Ethernet 1 or the RJ45 port can egress out 2. Everything else is excluded. And conversely, anything ingressing on port 2, can ingress in port 1, or sorry, egress on port 1. And you can do this on all three of these settings. You don't necessarily need to, depending on what your application is, but in this case, for the example, I did that. Another one would be maybe USB, the gigabit USB bridge to 100 base T1. Very similar, just connecting two ports and excluding all the others. Two things to note when you're using when you're using it as a media converter like this, a switch is by default a store and forward device. That means it will receive the entire frame before sending it out the port. So it goes completely in, gets put in a queue, and then it egresses. So that inherently adds some latency to the traffic. And there are, in Jupiter, later we'll talk about, there is a configuration that you can bypass that and have a cut-through device, but for Pluto, it's limited to store and forward. And then ideally, you'd if you're using this as a media converter, you'd statically configure the L2 address table just so there's no initialization. But you could also just make sure it's configured to flood the ports with unknown addresses, and it'll configure itself almost immediately. Another simple configuration is port mirroring. I'm showing on the screen here, I have 4 different devices: the body controller, center stack amp, and rear seat entertainment. And let's say I want to see traffic only on certain ports, and maybe even only in certain directions on certain ports. You can do that with this configuration. So you define the mirror port with a drop-down menu here, and that can be any of the 5 ports of the switch. And then down here for mirror, the ingress and egress. So that means anything that ingresses on port 2 is going to get forwarded to the mirror. And anything that egresses on port 2 will get forwarded to the mirror. So depending on what type of traffic you're interested, you can filter it just on incoming traffic or outbound traffic from your DUT'S or traffic from one DUT to another. You can set it up in this configuration here. So gang testing, identical device under test. Automotive doesn't always follow the rules, and what I mean by that is, in the IT world, every piece of hardware having a MAC address is intended to have a unique MAC address. This computer has a unique MAC address. This USB dongle has a unique MAC address. It's effectively a serial number or identifier that's only associated with that piece of hardware. In automotive, they chose not to follow that standard, and that's perfectly acceptable. It's a closed network. They enforce the rules. They don't have to follow the rules. They just want to make sure that it works the way it's intended at the end. So, and why would they do that? Well, conservation of MAC addresses. Every MAC address has, well, there's a finite number, of course, and then there's a cost associated with that as well. And then also it simplifies development, manufacturing, and diagnostics by having common MAC addresses across for a given ECU. So you'll see if you're trying to use a switch for a test application to connect to multiple devices of the same kind, you're going to have address conflicts on at least 2, maybe 3 layers. You've got MAC addresses that conflict, you have IP addresses that conflict, you have port addresses. In switches, I mean, we can really only manage layer 2. Because if you're talking about layer 3 manipulation or route, we're talking about routing and basically layer 3 devices. So let's say you were dealing with UDP traffic. So outbound UDP traffic from the test application, a multicast one-to-many is not difficult at all. It's connectionless. It really doesn't matter. So test application can send out a UDP datagram on port 100. The switch will send it out all ports to all the DUTs. They'll all receive it, and everything works great. On the return, many to one, it's not that simple. So you have 4 identical devices, identical IP addresses, identical ports. When that all gets forwarded back to the test application, it's not going to be able to make sense of what device sent, which information. So I'm going to talk about VLANs, and so VLANs were really initially defined for virtual networks and managing virtual networks across common hardware. So switch devices only receive traffic that they are a member of that VLAN. So the VLAN information's in the Ethernet header. It defines a VLAN, an arbitrary number that just defines which VLAN that is. It also has some priority information that the switches can use to determine what priority queue for the frame to egress. So the switch will route frames based on VLAN configurations or restrict routing based on VLAN configurations. And this can be static, where you go into the switch and statically define these VLANs, or there's a protocol, multiple VLAN registration protocol, which allows devices connected to a switch to request belonging to that VLAN. So VLAN terminology. So if you hear the term default VLAN, that implies that any frame that ingresses on a given port will be tagged with a default VLAN. So the default VLAN tag that's defined. So when there's no VLAN, the default VLAN assigned, there's no VLAN. Otherwise, it's tagged on ingress. Then you hear VLAN member, and what I've found is that definition can vary depending on the manufacturer of the IP or whoever's doing the configuration utility. It may define ingress rules, saying only frames with that belong to the same VLAN can ingress, or it could belong to the egress rules, or both. So I have a little tag in the bottom here. So make sure that you understand the nomenclature of the devices that you're using. I've looked at Broadcom, I've looked at NXP, I've looked at Marvell, and all of them, I mean, the terms and the concepts are the same, but the nomenclature can be a little bit different. Then you have an untagged port, and so anything matching a VLAN with a matching VLAN tag is allowed to egress, but as it egresses, the switch removes or untags that frame. And that's usually to connect devices that are not VLAN aware to a specific VLAN. And then you have tagged ports or trunk ports, and those are ports which typically belong to more than one VLAN. VLANs go in and out unmodified, and it's really intended for the trunk lines or the backbone that connects switches. So you could use these VLANs to tag each device's traffic with a unique VLAN tag. So what you would do is, for physical port 1, you could say VLAN tag 101, physical port 2, 102, and so forth. So by the time the test application receives these frames, they all have a unique VLAN tag, and so you can discern which device was sending which UDP stream. One note though, confirm how your hardware handles VLAN tags. If you're using Windows and a stock Windows driver, some drivers strip the VLAN information out before it gets passed over to Windows, and that can cause some confusion. If you're using, logging equipment and, kind of bypassing Windows, the logging equipment's timestamping it and placing it in a log file, you should be okay. But if you're using the NIC on your computer and Wireshark, you might be a little confused. And there are some Windows compatible devices where you can go into the driver and enable this. Sometimes it's straightforward, sometimes it's not. So to define a VLAN, first thing you do is assign a default VLAN for each switch port that's connected to a DUT. So here you can see, as consistent with the last slide, I have 101 for port 1, 2, 3, and 4 for ports 2, 3, and 4. Then you need to define the VLAN itself. So you go into a VLAN lookup table and you have a line item for each VLAN. And there's 5 properties that define the VLAN for NXP. We're concerned with 3 of them. The vmemb, the VLAN member, that is related to ingress policing. So if that box is checked, it will let the VLAN pass. If it is not, it will not let that VLAN pass. The broadcast port, this means that broadcast messages on this port can be blocked or restricted. And then the tag port is what I mentioned before. If the checkbox is enabled, that means the tag will be intact when it leaves the port. If you uncheck that box, it strips the tag on egress. So now we'll talk a little bit about RAD-Jupiter. This is our second switch that's going to be available this year. It's a 7-port managed switch. It supports AVB and TSN. It also has the same CAN and LIN and Core Mini capabilities. Looking at its block diagram, it uses the Marvell 88Q5050 switch. So it has 5 integrated 100 base T1 PHYs. Another port we muxed between 1000 base T and 1000 base T1, or two-wire Automotive Ethernet gigabit. Another port we muxed between the USB 3 gigabit bridge or another RJ45 port. And then we have the Core Mini processor on its own port. So in this one, you don't need to mux between being able to use the Core Mini processor and scripting and basically be giving up a port. Similarly, you can do media conversions. It's similar to Pluto, different configuration interface. It's got 2 more ports. It's got the gigabit 1000 base T1. This one does have advanced configurations that will let you set things up as a cut-through port. There are some constraints, and there's a number of factors that need to be taken into account when you do this. That's why I say advanced, because it's not a matter of just going in and setting a register or two. You kind of need to understand what trade-offs you're dealing with. And this is what I mean about different terminology for different VLAN terms. So when you configure the port-based VLAN on a Marvell switch, it implies that the ports need to be a member of the VLAN for ingress, and they are members for egress. But it's a much simpler table. It's just a simple ingress rows and egress columns. Another area you might be interested to use this in testing is for testing gPTP, generalized precision time protocol. And this requires a managed switch because it has a host processor on there that has responsibilities of collecting timestamp information to measure latencies and delays, as well as the ability to transmit that information across the network so that all the devices on the network have the same information. So it requires a managed switch. So fortunately, Jupiter is a managed switch. So if you wanted to do gang testing on where you have a bunch of gPTP slaves, it's not incredibly difficult. You set up the Jupiter as a grandmaster. There is a one hitch in that gPTP traffic is not forwarded, and that's by design. So the switches handle this traffic differently. It's a destination address reserved for, I think the most common is the LLDP, Link Layer Discovery Protocol, but it's also used by gPTP as well as some of the other AVBs. And so what that means is it is not forwarded under any circumstances, but you can bypass that with the hardware in here with port forwarding. And then there's another resource in here called TCAM, which will let you set up special rules to handle traffic in unique ways. So it's similar to the previous example using VLANs, but in this case, instead of just setting up VLANs, you need to actively set up a rule or port forwarding so that the messages get back to your test PC, your test application. Now, if you want to test a group of masters, you can't set, the way things are defined, you can't have a switch or a bridge have more than one slave port. But in this case, depending on how you're testing it, if you're just looking to confirm that the gPTP masters conform to the Avenue test requirements or your customer's test requirements, you don't necessarily need a slave. So you disable the gPTP altogether on the Jupiter. You have the same VLAN and port forwarding as the previous example, but in this case, because of the way gPTP works, you need to script a simple message to go out and request some information that the masters, when they're configured as a master, should respond. So this works pretty well for the automotive profile because of the way Avenues defined the behavior. If you're using the standard profile of gPTP, there may be some additional scripting involved, but it's it's fairly trivial if you understand what the state machines are expecting. So gateway functions, I'm not sure when they're going over the gateway builder functionality that we have in Vehicle Spy. Currently that is not supported. Ethernet is not supported yet. It is in the plan, but at this point it is not fully supported. But you can still do gateway implementations using function blocks, a C-code interface. If you saw the vSpy-X discussion earlier, so now we're talking about Python, those can all be enabled in the core mini processor to do a number of things, passing information back and forth between networks. So you could do something as simple as have a CAN frame come in and then define anything defined in the DBC or like a LIN table, pack that into a UDP frame. You could have one port for everything. You could have assign the ports based on R by D of CAN. Really, it just depends on how you want to use the other side of that gateway. The last feature I'm going to talk about in Jupiter today is called Ternary Content Addressable Memory, or TCAM. This is a really interesting capability. I've been playing with it a lot lately, but it's a method of packet inspection. So you have a bit mask that you can apply to the first 96 bytes of the message. So that goes well into the layer 4 header. Well, it passed the layer 4 header, I guess. So ternary, because it can be a 1 or a 0 or a don't care. And so when you set that mask and you have a hit, the switch is able to do certain things with the messages at what they call wire speed, or basically no latency, discernible latency. So what that can do is you can literally on anything in the first 96 bytes, you could drop a message, forward a message to specific ports, override destinations, manipulate VLAN tags, reprioritize things, or if you're a tier 1 or an OEM and you have a host processor on there and you're writing your own applications, you can have that frame tagged specifically to go to the host processor for things like deeper inspection, cybersecurity, complex ingress policing, temporal filters and things like that, or gateway to another network. And this is very simple to configure. This is the GUI from the Marvell. But you'll see up here, it's literally you define the data and then the mask. In this case, I'm looking for a specific ether type, 22EA, which is the stream reservation protocol, and then the multicast address associated with it. And if that's hit, anything from port, in this case port 2, is an action is taken to override the destination vector. So I set this up because their switch didn't support a protocol I needed it to. So anytime the message came in from that protocol with this address, I had it forwarded to the ports that I needed it to. And it was very simple. It took me all of 5 minutes to set up. So what could you use this for? Well, all kinds of things. Hardware filtering, if you are you're constrained with your laptop and you have a high amount of traffic coming in, you can basically put all the heavy lifting onto the switch and have it drop all the frames except the ones you want. You could have it straight down to specific port or anything up into the layer 4 header. You could do frame dropping, and this might be interesting if you're trying to induce errors on AVB or TCP. So you could have in AVB, for example, in the transport protocol, there's a sequence ID, and so ideally all the numbers or all the frames come out in sequence. But if you drop one, what happens? So you could set a TCAM filter so every 16th frame it drops, or you could enable it dynamically or change when it drops. So you could have this done in hardware, so you're not trying to do it in scripting. You could change VLAN priorities or strip them all together. What happens if all of a sudden your AVB, what if you just stripped all the VLAN tags off AVB? What's it going to do? Is it going to behave gracefully? What if you inject, take another class of traffic and all of a sudden raise it a priority. What does that do to your network? Is it going to behave gracefully or not? And then other things, inject traffic, denial of service. You could set TCAM rules to anything coming in this port, just blast it out another port at a higher priority, and try and spoof information as well. So any one of these, it would be very simple. If you have an idea or concept that you'd like to try, by all means, stop by or get my card. And it doesn't take any time at all to prototype this stuff and just see if it's going to do what would be useful for you. So that's all I really have. Any questions regarding the switch products we have, capabilities?